this video I'm going to go through part G of question 1 on the Math 2010 paper. So here we have a function f which is defined for whole positive numbers, and it satisfies f of 1 equal to 1, and these two rules, so f of 2n is equal to 2 times f of n, and f of 2n plus 1 is equal to 4 times f of n for all n. And we want to know how many n satisfy f of n equal to 16. So we can work out a few of the terms just to get a feel for what's going on. So if I call this rule 1 and this one rule 2, we already know that f of 1 is equal to 1, and for f of 2, well, 2 is just 2 times 1. So using rule 1, then that's just equal to 2 times f of 1, which is 1, so that's 2. And for f of 3, because 3 is 2 times 1 plus 1, then we can use rule 2 to get that f of 3 is equal to 4. And for f of 4, well, 4 is 2 times 2, so we can use rule 1, and so we get that that's times f of 2, and f of 2 is 2, so that's equal to 4. Then for f of 5, well, 5 is 2 times 2 plus 1, so if we use rule 2, then it's going to be equal to 4 times f of 2, so that's 4 times 2, which is 8. So you get the idea. Each time we're either multiplying by 2 or multiplying by 4. And so if we're starting off from 1 and we want to get to 16, how can we do that whilst only multiplying by either 2 or 4? Well, either we can multiply 1 by 2 4 times, or I can multiply by 4 twice, or I can multiply by 2 twice and 4 1 times in some order. And so if I remind you of the rules that we have, then this first one is equivalent to using this first rule 4 times. The second one is the equivalent to using rule 2 twice. And this last one, we're using rule 1 twice and rule 2 once in some order. So for these first two, there's only one option for what we're doing. Either we're using rule 1 all the time or rule 2 all the time. So each of these is only going to give me one number. But for this last one, we can do rule 1 and rule 2 in different orders, and those orders are going to give us different numbers. So for example, if we did rule 1 twice and then rule 2, well, when I apply rule 1 first, then that's going to tell me what f of 2 times 1 is, so that's f of 2. Then when I apply rule 1 again, that's going to tell me f of 2 times 2, so that's f of 4. Then when I apply rule 2, well, that's going to tell me f of 2 times 4 plus 1, which is 9. So doing it in this order tells me that f of 9 is equal to 16. But if I did rule 1, then rule 2, then rule 1, then, well, when I apply rule 1, we get f of 2 again. Then when we apply rule 2 to f of 2, well, that's going to tell me what f of 2 times 2 plus 1 is, which is f of 5. And then when we apply rule 1 to that, well, then that's going to tell us what f of 2 times 5 is. So that tells us f of 10. And so doing it this second way tells us that f of 10 is equal to 16. But the answers that we got from the two different orders isn't the same. So how many different ways can I order these two 2's and the 4? Well, either I can do the 4 last, or I can do it in the middle, or I can do it first. So we see that we get 3 different orderings for these, and so that means that that gives us 3 different numbers. And so in total we have 1, 2 plus another 3 is 5 different n, such that f of n is 16, and so the answer is C.